Alright, so this video is hopefully going to be an awesome video. This is what really got me interested in Mars in the first place, was the possibility of water on Mars, both in the past and frozen now. This video is more on evidence for water in the past, and there's two main types of evidence. Basically, they are runoff channels and outflow channels. Let's start off with runoff channels. So these are similar to rivers and streams on Earth. They're not huge. I mean, they can be big, definitely, but they're not planet-wide huge like the outflow channels are. They're located in the southern highlands, which means they're old. If you remember, just do a quick little recap here. Let's go to elevation and zoom out. If you remember, the lowlands, the northern lowlands, have very few craters, and so the surface is newer. The highlands in the south have lots of craters, and so it's older in general. Most of the runoffs that you'll see on Mars, if you were to look closely, happen down here, which leads people to think a few things. First, um, Mars would have been, first off, the runoff channels are old because the southern highlands are old, and very early in Mars's past, which we're talking about like roughly 4 billion years, maybe half a billion years after Mars formed, it's thought that Mars was warmer, had lots of liquid water present, and the atmosphere was thicker. Having a thicker atmosphere allows for basically a higher pressure in the atmosphere, which means that water can be liquid at water can be a liquid more easily. It doesn't have that pressure. It has pressure keeping it from boiling away much more easily. And so it's thought that the runoff channels would have been caused potentially by rainfall, although there's debate about this, but potentially from rainfall that running from mountains down to low valleys. So, for example, here's a couple pictures, and um, you would have higher areas, and then say rain, which would typically cause streams. If you've ever gone mountain climbing, you've seen these streams coming down mountains. They're often good for replenishing your water supply if you have some good filters. And they would go and spread out, thin out, and form very similar features to what you see on Earth. Here's some other examples. Let's check out Google Mars and see if we can find some more. Bam! So here we are in the southern highlands. How can you tell? Crater, 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 crater. I dare you to pause this video and count all of the craters in here. I dare you. Anyway, what do you notice over here? Going from high areas to low areas. Well, let's change the view because we're used to seeing this Google Mars in elevation view. Let's go to visible. See if we can see some detail there. And zoom in around here. Ooh, pretty. Look at that. So we got a high crater, and this is most likely an old crater. And well, maybe. Actually, this looks like more of a new crater. These look more like older craters, don't they? Because they're more eroded. But and this actually might be even an older crater. Anyway, so you can see though that you got some sinuous little paths coming down from high into low areas, and it may even be more clear in infrared. Let's check infrared and see what we got. Ooh, maybe. Yeah, get a little more detail. You can see some shadowy things here, and definitely paths that what else could have formed these besides water? Maybe lava in some cases, but there's not much volcanic activity, if any, down here. These are old and not covered up by lava. The newer surfaces, the younger surfaces, I should say, on Mars, are the ones that have been covered up by lava. So that's one example. Let me try to find another one. Bam! Alright, so we were just looking over in this area. Over here we got some interesting features. We're also going to check this area out again later on for outflow channels, but let's zoom in around here. A little slow. Whoa! Ooh, there we go. Look at that. Look at that. Let's change to visible. And zoom in a little bit. Look at those. Beautiful. Maybe we'll get even a clearer picture in infrared. Not too bad. We're missing a piece here, but you can definitely see some long, sinuous looking paths that water would have flown. Water would have what do you call it? Just flowed through. Sorry, and yeah, it's higher up here and lower down here. So as water flows downhill, it gives you an idea of the general direction. So that's those are some examples of runoff. The other type are outflow channels. They look like huge, huge rivers, but they're probably more just evidence for huge amounts of flooding, often called catastrophic flooding, meaning if you were standing in the path of this, you probably have catastrophically done something to yourself. Um, Let me not waste a few seconds zooming in because Google Mars seems a little slow right now. Let me pause. Bam. All right. So the two examples of runoff channels I showed you were around here and around here. Can you see them at this zoom level? No, because they're tiny. Can you see these? Oh yeah, these are huge. I in a recent video, if not maybe 2 videos ago, I told you just how big Olympus Mons is. 700 uh, kilometers across, 600 kilometers across, or just huge. The Look how comparable these are. These flows here, just these are big. These are most likely not rivers. That's a lot of water to sustain a river that big, and so most likely they are um, outflow channels. Basically, for some reason, and notice these are kind of near volcanic areas, right? And look, where do these come from? Looks like they're because water flows from high to low. Red is high elevation, blue is low elevation, and so water would have flowed this way. I keep wanting to say flown like it's a plane, but it looks like it started off in this area, and something, if truly this would have been a catastrophic flooding, maybe melting groundwater or some large source of water, or maybe, well, there's plenty of theories, but anyway, it would have caused it to just flow in a short amount of time and just go this way, and so it wouldn't have been a long sustained flow like you have in a river or in a runoff channel. These are located more near the equator, and they form some interesting features. We got teardrop shaped islands, and they form wide and long channels, as we just saw. Here's an example of teardrop shaped island. Let me find one in Google Mars here that you can see. If I remember right, there's one over here somewhere. Let's zoom in. And let's see if I can find it. Oh yeah, there it is. And it looks better in God, Google Mars is slow. It looks better in infrared, I believe. Or maybe it was visible. Yeah, look at that. It's a nice teardrop. So you would have had water flowing from the bottom of the screen to the top, flowing on, and then suddenly it hits this crater. And the crater, if you remember, it has walls, kind of. These these go up high. They're kind of like a hill, and then it goes down deep into the ground like a hole. And so this is kind of like water hitting a dam or a wall, and so it's just diverted around. Of course, in that making that path, it forms this teardrop shape before the water meets up again. So you got water coming, splitting up, some water going this way, some going this way, and eventually farther down it meets. So you see a bunch of tear-shaped islands. There's kind of another one here, and it looks like this crater is round and probably either formed after the flow or the flow kind of just went around it gently. Maybe who knows? Um, Let me get rid of this Google Mars real quick. All right, so yeah, teardrop-shaped islands, long channels. These actually are near Hellas crater, Hellas Basin. Let me show you that real quick. Actually, let me bring Google Mars back. Here it is. Let's go to Hellas Basin real quick. I'm gonna pause. All right, here's Hellas Basin, and you can see we're zoomed out quite a bit. You know how big this thing is. See these two paths here? That's uh, that's these two. Let's look at it again. Let's zoom in. Whoa, too much. Zoom out a little. And so you can see those. And these things, again, water flows from high to low. So in this case, they're flowing down into Hellas Basin. And what's interesting here is these start off wide and get narrower because you got water being absorbed and doing other things. So as being catastrophic flooding, it just flows over a brief amount of time. It doesn't have time to kind of spread out and form new channels that you see in the runoff channels. So you get like a big pile of water here, and it just something lets it loose or melts it quickly or does something, and the water just floods down, almost like a big landslide. Um, so yeah, the debate. So there's a debate still, although evidence seems to be pointing more and more towards the warm, wet past theory. But not everyone's convinced about that. Were the runoff channels caused by rainfall during a warm, wet past, or was it caused by just periodic melting of underground ice, for example? Near Holden Crater, you have this, what some scientists think is a river delta. A river delta on Earth. Let me show you that real quick. So here we have Earth, and this is the Nile River, and you can tell it's pretty obvious the river. So you got like desert, and then trees, right? Then at the end, look how the green just spreads out. So this is a delta on Earth, basically, where the water kind of exits out. And if I zoom in a little more, you can see the different streams. Here's the Nile, and it kind of spreads out over here and over here, and just if you zoom in even more, you get smaller and smaller little streams going out. That's a river delta on Earth. Is this a river delta on Mars, where you get things kind of spreading out, or not? That's near Holden Crater. This is actually in Holden Crater. Is this a receding shoreline where you have like water at one level and then the water level gets lower, and so the shore marks happen a little up more? Here's another example of that. Or is that just geological activity? Scientists claim on both ends. Whoa, I'm at 14 minutes. Let me pause for a second, think about how I'm going to end this. Alright, so I just want to show you Holden Crater real quick. This doesn't have enough detail to show you the receding shoreline, but I just want to show you one last outflow channel. You can see lots of water flowing out here, and then some of it kind of going off to the side here. Looks just like a river, huh? It kind of spreads out a little bit, and there's been a lot of water flowing through here. And continuing on down here, maybe even filling these in as lakes. But anyway, I'm running up on 15 minutes, and I won't be able to upload after that. So I hope you enjoyed this, and see you later.